Okay, welcome to an Arduino lesson. This one is called Blink, and it's going to be your first time that you're using the Arduino to control a component. It's called Blink, and we're going to turn an LED on and off. Okay, an LED, well, we have two types of components for the Arduino. We have outputs, which we're going to be working with, where we send a signal from one of the pin numbers to a component like an LED. We can turn it on or off. We can make a motor move. We can make a servo move, or we can make a buzzer or a speaker make some sound. Those are really the only outputs that you'll be working with. And then we will also be in the future looking at some inputs like button switches or volume knobs or other sensors that you can use to get information and then control outputs. So we're just working with the inputs now, and it's a very small amount of code to make it work. But it's the start, okay? So what we've got here is the Arduino, the breadboard down here. Remember, the breadboard is set up in a way where the power rails for the negative or the ground are in blue, and in red we have the positive or the 5 volts in red, and that's the first thing we're going to set up. So I'm going to go from the ground. It doesn't matter which one I go from, but in fritzing I put this one close, so I'm just going to take this and pin it right there. And if I click on it, you can see it's saying, hey, the grounds and the whole blue power rail is now a ground, and anything I plug into those yellows will actually be part of that circuit for ground. Then I'm going to put 5 volts, which is our positive, into the positive power rail, and I've connected that up. Since we want to keep color coded, I'm going to change this color to red. Okay, everything ground, anytime I come from this power rail, I'm going to use a blue wire, and anytime I come from the 5 volts power rail, or the red, I'm going to use a red. And that'll help us see where the ground wires are and where the 5 volt positive wires are. And it makes it easier to troubleshoot. Anything coming from the number pins, which we're going to use to control the LED, would be another color. Okay, so here's the LED. The LED has a long end called the anode. That's the positive side. And a short end called the cathode, and that's the negative side. I think I put that over here. Okay. So you kind of need to know that. Each component has at least 2 things you need to hook up. Some of them have 3. And it's pretty simple to find out how you have to hook them up by just typing in LED Arduino or LED fritzing. See, and it's showing you how to hook it up on the breadboard. So this is something that if you should never have to ask me how to hook things up or ask your teacher how to hook things up. You can Google it, and I've given you a cheat sheet, and there's plenty of YouTube channels that you can kind of get back to and learn the wiring. But we're going to take the LED and we're going to put it into 2 pin rails, or the component rails here. So this one's going into this, so those yellow dots or that whole, vertical line is all part of that cathode now. I'm sorry, the anode. And the shorter end is going into this set of component rails right here. All right. Because an LED actually only needs 3 volts, putting it into the 5 volt would actually, it would heat up and then it eventually burn out. So we're going to use what is called a resistor, and a resistor just slows down the current, so it's less current going through the LED. You will have to use these with LEDs if you want your LEDs to continue working over time. It'll work for a while, but then eventually it'll start to burn out. So let's just follow the circuit. Let's delete this line. Boom. Boom. Okay. So first of all, in order to control the LED, we're going to use one of the pins. And any of these pins work, pin 13 all the way through 1. The only thing you need to know is that when you choose a number, you need to tell the code that's the number that is hooked up to the LED. So we're going to use pin 13, and we're going to come right down to the long leg, the anode, and I'm going to change the color of this wire to yellow, let's say, because that's a special wire. That's a special wire that goes from 13 to the positive end of the LED, which is the anode. See, right there. Then we need to complete the circuit. The other end needs to go back to ground. All components will go back to ground. So what we need to do is we can use this resistor here. Okay, now the resistor is hooked up into the same rail. Let me see if I can pull this over. Let's see. Here we go. All right. The resistor is going into the same component rail, pin rails, as this short end of the LED. The other end can go into any other one. So now it's in this one. Let's see. And then I need to continue on to the negative power rail, or the ground. So this wire should be blue. Okay, just to repeat. So I'm going to tell the computer to send us, or tell the Arduino to send a signal to pin 13 to turn it on. The voltage will flow down this yellow wire into the breadboard, up this anode, into the LED, light it up. Then down, the current has to continue down the cathode, into the breadboard, through the resistor, which slows the current down, then into this breadboard rail, and then from this wire back to the ground, and then back to the ground. That's a perfect circuit. All we need to do is write the code. And really, there are 3 lines of code that we need to fit in. So I'm going to do that right now for you. All right. So, and it's pretty simple. So I'm going to go File, New. I've got a new sketch. So the programs in Arduino are called sketches. There are 2 things that automatically pop up. One is called void setup, and one is called void loop. Void setup is a program that it runs once. Notice it says that right there. Runs it once. And so there's only 2 things we put in here. One is called pin mode. Pin mode is a function that tells the Arduino which pins you're using. So you'll have a pin mode for every component, or for every pin number you're using. So you type pin mode with a capital M like that. It's got a hump in the middle. They call it a camel case, just so that this function is not something that you would write normally. Then you put in parentheses. The first thing you write is the number of the pin that you're going to use. We're going to use pin 13. Okay, if we're going to use pin 10, we'd change it to pin 10. If we were going to use pin 1, we'd change that number to 1. We put a comma, and then we have to denote, is this an input or an output? That's it. So this is an output, meaning it's an LED, or maybe if it was a servo or a motor or a buzzer, we could put that as outputs too. Okay. And then we put a semicolon. Every line of code will end with a semicolon. Okay, that's it. Void setup is ready. The pin 13 is now set as an output, and we can control it by sending voltage to it. There's some things to be aware of. Void setup and the 2 parentheses, that's something that you don't have to worry about. But these curly brackets are kind of important. They enclose the program, so it knows, hey, there's a program here starting here and ending here. And if you click on a curly brackets, you'll notice it tells you where the other curly brackets is. And it's important because if you delete this, it'll tell you an error at the bottom saying you're missing a curly brackets. All right. Another thing I want you to start doing is using comments. So if you do // like this, anything you write, it will ignore. So like this is a comment right here. So right here, I'm going to tell just write a comment that pin 13 was set to the LED output. Okay. All right. So pin mode is the only function you use in void setup, except for one called serial begin. And I'm going to talk a little bit more about serial begin, but I want you to get used to 9600. Serial begin, serial.begin with a capital S, 9600 in parentheses, and then another semicolon to end. This opens communication monitor, or the serial monitor. It's going to become very important to know what is happening in the Arduino, and you can see if buttons are being pressed or if variables are being set. We'll come back to that. It'll make more sense later. But just get used to putting that in void setup with your pin mode. Okay, it's good. So let's write some code that tells the Arduino to turn the LED on. The code is, since it's digital write, the pin number, and then either high or low. The LED can either be on or off. So what we're going to do over here is write digital, capital W, write. It instantly turns red, showing that it's a function. We tell pin 13 we want to turn it high. It's just like output and input. These are all caps, and they turn blue because they're values that are set. So high is really a 1, or turn it on. I'm going to put a comment here, turn LED on. And then underneath it, I'm going to write digital write. I'm going to tell it pin 13, and let's turn it low, which is off. Semicolon, // turn LED off. Okay. So what's going to happen first is I'll run the sketch. It'll do the void setup, which is set the pin mode 13 to an output. Again, this is always going to be the number of the pin you're talking about, and this is it an input or is it an output? Are you receiving information or are you sending information? So the LED, we're going to send information to the LED, then we turn it on and off. The problem with this code is that it would turn it on and off so fast that you wouldn't really know, because it's happening in milliseconds. So we need to slow it down a little bit. We can do that with a very easy piece of code called delay. Delay does that. It just delays the program for a certain amount of time. And so in parentheses, all you do is write in milliseconds how much time you want to delay. And in this case, I'm going to put 1,000, which would be 1 second. Delay 1 second. Okay. And then after it turns it off, you want to delay, turns red because it's a function, another second. Period. So what void loop does, it just keeps playing this over again. It'll turn it on, wait a second, turn it off, wait a second, and then it'll go up here and loop it again. Turn it on, off, each with a second between. Okay. So up at the top, there's a couple of things you need to be aware of. One is tools. Make sure your port is, I don't have mine plugged in, so I don't have the port. But it should say something like 1431 or something. You'll see that it's looking for the Arduino, and just make sure that you're on an Arduino board like the Uno. If you have a mistake, like I forgot the semicolon, when you try to upload it, it does a verification. At first makes you want to save it. I'll call it blink. Okay. It'll first do run the program in the computer to check to see if there's any problems before it uploads it to the board. And it stays on the board until you send another program. Right here it tells you at the bottom expected semicolon before the curly brackets. And you can kind of come up here, it highlights the area, and you go, oh, I just needed a semicolon. Okay? So this just runs the program in the computer, verify. So it compiles it, it's compiling down here. It says compiling complete everything looks good, there's no errors, I can upload it to the board. So that's your first program. You can change these delays to make it blink faster or slower. It's as easy as doing this, copy and paste, and now it will blink. And if I wanted to put in 500 milliseconds here, it would do more like a heartbeat. If you want to do something a little more difficult, why don't you plug in another LED, a different color maybe, and put it in pin 12 and make it an output too, like that. And then have one on when one is off. So digital write 12, we're going to start low, and they're gonna alternate. And what's great about this is you can just copy and paste code very easily. And, you know, like I know this is going to be high again, and this is going to be low again. So I'm just so now I could hook up another LED and come from pin 12, have another resistors, and go back to ground. I guess why don't I do that right now? Let's see. Okay, so I would take an LED. Here's the long end, and I could put it right here. I could go from 12 to here. Since it's a pin, I'm going to change the color to orange right there. Okay, I'm going to pull this leg over here so it's a little bit more easier to see. So there, it's going to the same anode. It's going up into the LED. I need to return it to the with a resistor, so I can put this resistor here. I actually can go back. It doesn't matter. This ground is the same for everyone. So if I come from pin 12 and go through the LED and through the resistor, I can go back through the same ground. It doesn't matter. Everybody, all your components will end up in the same ground anyway. So you can use the ground of this LED as well. Or if you wanted to, you could give it its own ground. You could do this as well. Change that to blue. So play around with that. Try to hook up as many LEDs. Turn them on and off using digital write and digital write low, and just your pin modes. And we'll get back to some more complicated LED stuff in the future. Thank you very much.